All right, we're about to pull back the curtain on a secret that's humming away inside pretty much every single piece of tech you own. It's the hidden heartbeat, and it's powering your entire world. So let me ask you a kind of weird question. What on earth could your smartphone, your car, and your microwave possibly have in common? I mean, they do totally different things, right? One connects you to the internet, one gets you to work, and the other warms up your leftovers. But believe it or not, they all share this fundamental, totally invisible secret.
And that's the big connection. Deep down in their guts, inside their circuits, every single one of these devices depends on a steady, perfectly timed pulse. It's a constant electronic rhythm, a heartbeat that makes everything else work.
So, what is this heartbeat? Well, in the world of electronics, we call it an oscillator. And honestly, if you want to understand how our modern world actually functions, you've got to understand this little guy. Okay, so what exactly is an oscillator? You can think of it as a magical little converter. It takes a boring, steady stream of power, direct current, and transforms it into this lively, repeating signal, a wave. And the really cool part is, it does this all on its own, just continuously, without needing any prodding.
And here's what that looks like in practice. See, on the left, you've got direct current, DC. Think of the power coming out of a battery. It's steady, it's a flat line, but it's not super useful for complex stuff. The oscillator is what takes that flat line and creates the rhythmic wave you see on the right, alternating current, or AC. That is the pulse. That is the heartbeat.
But wait a minute, how does it just create this pulse out of thin air? Well, the secret is a concept that I guarantee you've experienced yourself, probably without even realizing it.
You know that awful high-pitched squeal you get when a microphone gets too close to a speaker at a concert? Yeah, that's a positive feedback loop. The mic picks up a sound, the speaker makes it louder, the mic picks up that louder sound, the speaker makes it even louder, and it just spirals out of control into that horrible shriek. An oscillator basically harnesses that exact same idea, but in a very controlled, very useful way.
So let's break that down. It all kicks off with just a tiny random bit of electrical noise, which, by the way, is always there in any circuit. That tiny little signal gets fed into an amplifier, which makes it bigger. Then, and this is the magic trick, a very specific piece of that bigger signal gets sent right back to the beginning to get amplified all over again. As long as it's fed back perfectly in sync, or what engineers call in phase, the signal just builds and builds on itself, creating this awesome self-sustaining pulse.
Now, this brings us to a super important rule. You can't just throw any old signal back in there. To get a perfect, steady rhythm and avoid that chaotic microphone mess, the feedback has to be controlled with incredible precision. It can't be too weak and it can't be too strong. It has to be, well, just right.
Engineers actually have a fancy name for this, the Barkhausen criterion. But it's really just the Goldilocks principle. If the loop gain, that's just the amount of power in the feedback loop, is less than 1, the signal just fizzles out and dies. If it's more than 1, you get that distorted, spiraling chaos. But if the gain is exactly 1, bam, that's the sweet spot. You get a perfect, stable, rhythmic pulse, the perfect electronic heartbeat.
So how in the world do engineers hit that perfect, just right condition every single time? Well, for decades, the answer has been a beautiful, natural material that has a very, very special property.
The answer is quartz. Yep, that humble crystal is the unsung hero tucked away inside almost all of your electronics. It acts like an incredibly precise and dependable pacemaker, making sure that electronic heartbeat never, ever skips a beat.
So what makes quartz so special for this job? It all comes down to this really fascinating bit of physics called the piezoelectric effect.
It's this brilliant two-way street. If you physically squeeze or bend a piece of quartz, it actually generates a tiny bit of electricity. But here's the part that's crucial for our oscillator. The reverse is also true. If you apply electricity to the crystal, it physically bends and vibrates. And here's the kicker. It vibrates at an unbelievably stable and predictable frequency.
How predictable are we talking? Well, a tiny piece of quartz, shaped like a tuning fork, the kind you'd find in a watch, it's cut to vibrate at exactly 32,768 times per second. Now, why that super specific number? It sounds totally random, right? Well, it's actually genius, because if you take that number and just divide it by 2 over and over again, 15 times to be exact, you get exactly 1. 1 perfect tick per second. It is the perfect raw material for keeping time.
Okay, so we've got this tiny crystal buzzing away tens of thousands of times a second. Cool, but why does this one little component have such a massive, world-changing impact on our lives?
It's because that reliable little pulse isn't just a heartbeat, it's the master clock. It's the metronome that every single digital component is listening to. It synchronizes absolutely everything, making sure all the billions of calculations happening every single second are perfectly coordinated.
And when you look at what it powers, it's basically a list of modern life. Your computer's processor speed? That's its clock speed, and it's set by an oscillator. Your phone connecting to a cell tower? Your car radio tuning into a station? Your GPS figuring out where you are? All of it, every last bit, is completely dependent on the precise, unwavering pulse from an oscillator.
So here's the big takeaway. The entire digital symphony of our modern world, from the most powerful supercomputer to the simplest little digital watch, is marching in perfect time to the beat of this tiny invisible component.
It really makes you think, doesn't it? The oscillator is just one of these invisible heartbeats. What other incredible, hidden technologies are out there, humming away just beneath the surface, quietly running the world we all live in?